Okay, so the question for this one says array of monochromatic light. Let's get the pen. So array of monochromatic light passes into a glass block as shown in this diagram here. Right, so normally to calculate the refractive index, this is what we've been asked to calculate for the glass. Okay, to do that we use the formula refractive index n is equal to the sine of the angle of incidence divided by the sine of the angle of refraction. So these two, so in this case the angle of refraction and the angle of incidence is determined by, let's draw a line here. Gonna draw a line, and that line represents roughly the normal to the boundary. Okay, so this is the boundary, and it is at the boundary that the refraction is taking place. So we need to draw a normal. You can put dotted lines just to show, but I've used a different color, so I can use a solid line. Now, to find out what the angle of incidence is the angle between the incoming ray, which is that one. Okay, that's the incoming ray, and the normal. So this is the angle of incidence. Okay, the 55 is just put there to throw you off, but you can use the 55 because you know that this whole entire angle is 90. So if you say 90 take away 35, you get, see, I always do this, I've already put what the answer is. So 90 take away 55 equals 35 degrees. Okay, so actually this is 35, and that's the angle of incidence here is 35. Then to get what the angle of refraction is the angle between the refracted ray, because it's been refracted at the boundary, so that ray has been refracted along here, which means it's forming that angle, and that angle is a right angle, and the right angle is 90 degrees. Now when we have an angle of reflection or refraction of 90 degrees, then this angle becomes the critical angle. Okay, so actually 35 is a critical angle, and it has caused something we call total internal reflection, and this is mainly used in fiber optics for the transmission of data. Okay, so when we have a critical angle, we stop using that formula and we use this one instead. Okay, so the refractive index is going to be 1 divided by the sine of the critical angle, which means now we have n equals 1 divided by sine of 35. Now if you find the answer to that is going to be 1.74. Okay, so the answer is D, and that's done. Any questions, please ask in the comment section, and I will try to respond to them.